Okay, so today's Wednesday, 5/28. If you have to watch this from home, we're talking about wave superposition today. So let's go ahead and take a look at this. This is in your note packet, probably about halfway through. We're about halfway thugh this unit right now. Properties of waves. In contrast to particles, waves can occupy the same space at the same time. And this little picture here shows momentum conservation for those cars. Those two particles for those cars cannot occupy the same space at the same time. If they collide, their mechanical energy gets transformed largely into heat. A lot of that energy goes into non-mechanical forms. Momentum's conserved, but we lose a lot of mechanical energy. Particles cannot occupy the same space at the same time. Waves can, and when they do, they can pass right through each other, unaffecting their motion. So waves are able to occupy the same space at the same time. Raise your hand. You're listening to the radio stations at all? Any radio at all? How many radio stations do you think right now are broadcasting to this room? Like how many different radio? If I could tune my radio, how many different things could exist or could I tune to in this room right now? Do you think? 5, 10, 15? You could probably get 15 different radio stations tuned in this room right now. All of those waves exist in this room and they superimpose over each other. They don't change each other, they just superimpose. So they can't exist at the same place at the same time. Particles cannot. Now we have different kinds of interference. What happens when they pass through each other is that you have two different kinds of interference. One is a destructive interference. Raise your hand. Do you have any kind of noise canceling headphone access? Okay, noise canceling headphones take advantage of destructive interference. So if this is a crest and this is a trough, when they meet, those two things would superimpose over top of each other, and just for a moment they sort of cancel each other out. So those two things would destroy each other just for a moment, canceling out those two different waveforms. And your noise canceling headphones do exactly that. They sample the noise that's in the room, they create an inverted wave of that noise, and then feed that to your speakers to be able to cancel out that noise. And so those things would be gone for a moment. This is what you call destructive interference. So they momentarily destruct. And then afterwards, they continue on unharmed, if you will. So the blue one has passed through. The red one is on the other side now. And so waves can pass right through each other and not affect their motion. Now, if that's destructive, this kind of interference would be called constructive. And so constructive interference is when the waveforms add together to create a larger amplitude. Destructive is they would sort of cancel each other out. Okay, so constructive interference. Now, you're going to have to be able to do some wave superposition. What this is called when waves overlap is they abide by something called the superposition principle. So when they overlap, they momentarily interfere. The principle that describes that interference is called the superposition principle. Essentially, the superposition principle is saying that the displacements will add. So you add your displacements of those waveforms. Now, it's far easier to do this with square waves than it is with continuous like sine waves. So I'm going to show you how to add some square waves together. Square waves are very common in computer systems, and so this might have an amplitude of 1. This one might have an amplitude of 2. And when they overlap over top of each other, it's a fairly simple addition. These things would add together to give you a displacement of 3 just momentarily. And then afterwards, a moment later, they would just sort of pass through each other and be unharmed. I'm going to want you guys to try the next one. It's fairly straightforward to do. So if you have an amplitude of 1 and an amplitude of -3, they would add to a certain amount. And I'm sure that you can reason through that to see that this would be an amplitude of -2 for just a moment. The third one Probably the most complicated. I want to see if you're able to visualize it. Some of you have really strong visual spatial skills, which means that you're going to be able to visualize that one better than others. Give it a go. See if you can do it. Once you have that one drawn, the one to the right, share with that person that you're sitting next to and see if you are in agreement with them. So that waveform will. I'm going to ask for a volunteer to show what it looks like. So once you have that thing done and you feel like you got it right, I will not embarrass you, but if you have a waveform that you would allow me to show. Thank you. Nice. You just do that in your head. Okay, so again, some people have really strong visual spatial skills, right? So this is, are you a geometry person or an algebra person? Okay, so some people really like geometry because it's more of a visual thing, and some people really like algebra because it's more of a processing kind of thing, more like algorithm. So a lot of times people will find if you are a visual spatial learner that you'll sort of gravitate more towards geometry as your math of choice. Brad, thanks for showing this. So we'll see if this works. Okay. Reset.